Hello, welcome to the AWS Certified Cloud Practitioner training. Today is day one. This training will help us get trained and get certified within 2 weeks. 10 sessions of 1 hour each that will cover all the information that is needed for you to pass the AWS Certified Cloud Practitioner exam that AWS conducts. Today, we'll go over this certification. This certification is intended for IT folks who are starting out with the AWS. If you already have a lot of AWS experience, you may be easily able to complete this assessment. For non-IT folks, just getting into AWS, they can get certified using this course too. If you are in to like teams such as sales, legal, marketing, and helping out with marketing a AWS related product, it'll be good for you to understand and get this certification. It'll be you'll be able to do it if you're a business analyst, a project manager working in the IT field. What do you need before we start this? You need to understand general business knowledge with respect to IT and general IT technical knowledge. A little bit about myself. I have 16 plus years of experience in data management. I have a cloud architect certification from Google. Though I have been working for 3 plus years with Amazon AWS, this is my first certification that I'm getting, the AWS Cloud Certified Practitioner, and I got it in October 2021. As you can see, AWS provides a certificate that expires in 3 years. I just got certified last month in October. It's valid until October 2024. To pass the AWS Certified Practitioner exam, there are four concepts or four chapters that AWS wants you to go through. Essentially, cloud concepts is the first one, and it covers about 26% of the exam content. So it's a big concept, and that will give you all the basics of what the cloud is. Security and compliance is another 1/4 of the exam. This is another important piece as well, and it can get you through a lot of it. The most bulkiest part of the exam would be technology related questions. This could be any thing related to the multiple products that they offer. AWS offers multiple compute products, multiple database products, multiple data storage products, logging related information. So if you understand all of those terminology that they use, the networking terminology that they use, you'll be able to get 33% of the questions right. The last one is a smaller percentage, but it's important to understand how much AWS bills. If there is a cheaper option, how would you choose that, and those kind of aspects. Today, we just go into the cloud concepts, and we'll dive deep into it. We'll go through each of the cloud concepts, and then we'll get examples for those, and we'll also solve some questions that would come in a real examination related to the same cloud concepts, and see how you would solve them. For keeping our concept simple, we're going to take an example, and the example we're going to take up is an app that our company is planning to build. It's called Chatter, and just to keep it simple, we're going to keep it such that any person logged into the app would be able to send another person a message. And this application we're building right now only takes care of the peer-to-peer message. It is not going to be responsible for authentication or anything else. Those are all other applications within the company, and we're not concerned about it because our application just takes care of sending messages from one person point to another. This is going to be a simple chat application. We are going to understand how we're going to use AWS to build this, and what will happen if we build it using our own infrastructure. So we need the infrastructure to send and receive the message. So we need some kind of server which is connected to the internet. This could be like expressed in the terms of computing power and storage. So those are the major things that we'll require. There are other things that are such as networking that we'll require, security and compliance that we'll require. We'll take that up as the example gets much more solid. But to understand the cloud concepts, we just keep it really simple, and we'll just make sure that a user one would be able to actually send a message. It gets to a server, and then the server is able to understand who the user 2 is and then send it to them, and the user 2 receives the message. That is the simplest functionality we'll try to implement, and we'll try to see as we go along what infrastructure in AWS we'll need to set up to achieve this. So when the client 1 sends a message to user 2, the server has to evaluate the details of this request, and after it does that, it fulfills the request by returning the information to user 2 and then passing the success message to client 1. Again, to keep it very simple, we're not going to support multiple things that typical chat applications support. This is going to be only a text application, and only one-on-one chats can be done. We're not going to support group chats, just to keep it simple for us to understand the cloud concepts. We're not going to add any image, video, or file sharing capabilities. We're not going to indicate read receipt message. This is done by most messaging applications, but we're not going to worry about that right now. We're not going to have a mechanism to understand which user saw it at what time and then indicate that to other users. So let's start with the first key concept of AWS, that is, you pay only for what you use. So if you like contrast left, where we take an on-premises data center where the user sending messages to use other users is essentially done by a data center, which is a set of servers in a secure facility, and it's taken care, it's weather controlled, and it has to be in a secure facility so that other people are not able to access it, and all that infrastructure work needs to be done. That is the way you could do it in an on-premise data center. Another way that you could do it is using the cloud, and in this example we're going to look at how AWS can actually replace the on-premises data center, where AWS takes care of the server infrastructure, they take care of the networking, they take care of the way physically restricting people to get into the place, climate controlling it, and many other things. So in that case, we can replace these servers. To keep it very simple, I'm going to say we're just going to replace it with Amazon EC2 instance. One Amazon EC2 instance. This is not going to fulfill all our needs, but to start with, to test we'll be able to set up a server in Amazon EC2, and user 1 would be able to hit the EC2 instance, and that message would be able to send to user 2. Again, this is not the complete solution that we will build, but this is to test it to start with. I think we can use the EC2 instance, and EC2 instance is essentially a compute power that Amazon provides, and it's a virtual server. If you talk to people, they could use multiple names such as Amazon Elastic Compute Cloud, which is EC2, or they could say EC2 instance, or they could call it a virtual server. In all these cases, they refer to the same Amazon EC2 instance. The next key concept we're going to cover is on-demand delivery of IT resources over the internet with pay-as-you-go pricing, is what cloud computing is as per AWS. So as we saw, we need server, we probably need storage to build apps. How do we do that? We could actually do it over the cloud. So that means we do it using the resources that is those are available on the internet, over the internet, and those computing power and the storage is on demand. So we pay when we need it. So we pay only as you go. So if you spend more this month versus less next month, we pay more this month, and next month we pay less. And another month we need even more, then we pay even more. This is called scale up and scale down. And we pay on demand. That is, instance, if your chat application suddenly is downloaded by multiple people because of some viral tweet that somebody sent out about your application, so your resources needs are going to go up very heavily. You can go to the AWS console and immediately request for more information, and within minutes you can set up an infrastructure that takes care of more resources. You could also do this automatically, scaling up or scaling down. That would be another option as well. So what does it mean for our example, where we're building a chat application? So we are able to scale up and scale down based on requirements. So at first, when we are testing this, we don't need as many resources. And when we launch, we might need much more server capacity, much higher server capacity, so we can actually scale up when we actually go into production and have real users use it. And we could also scale down when we know that we have a lot more resources than are needed, and then we need to scale down, we can actually scale down. And this could also be a seasonal thing, where in summer more people use your app, while in fall many people like number of users come down. So you could actually scale down based on your requirements. And as you do this, you pay only for what is used. So you don't pay for the additional capacity that you never installed for the fall. So you just pay for the additional capacity that you installed in summer and used. And when you scale down and did not use that for the fall, you don't have to pay for that. Just contrasting that with an on-premises network, you would have to set up the server necessity for the maximum load. So if you think your maximum load would be a number, say let's compute it in MIPS or number of transactions per second, or number of transactions a day. So we have to set up server capacity for the maximum server load, because anything less than that would any time you get more transactions than the capacity, at that point of time there will be many failures. So to avoid that, you'll have to set up capacity which is much higher than the maximum load you think would be needed in the typical world. But in a cloud environment, you can actually scale up when you actually see this demand going up, and you can scale down. In an on-premises network, scaling down is pretty much impossible because you've already provisioned the resources, you've also already set up the infrastructure, you've already bought or rent the place where you're setting up your server, you've already set up the servers. So even if your demand comes down during fall, you will still have to pay for that. The next cloud concept we'll look at is an important point. It comes out subtly in certain AWS Cloud Practitioner questions. There are 3 cloud computing deployment models. Cloud-based, that is fully deployed in the cloud. On-premises, that is deploying resources using virtualization and resource management tools. So this is kind of a private cloud. So everything, all your software is still on premises, but you use virtualization and resource management so that you can utilize your resources to the maximum extent. The next one is a hybrid model where you have some of your resources on-premise and the rest of the resources are cloud-based, and you're able to connect between them and use them. This is the next important cloud concept, and this is very, very important piece for a lot of the questions definitely come from this concept. The 6 benefits of cloud computing, as listed by AWS. So I'll provide a link of the 6 benefits from cloud computing from AWS for additional reading. But let's go through examples of these. But before I go through, there are 6 benefits. We'll go through one by one. First one is in a cloud environment, we don't go for Capex. That is, we don't go for initial investment with a lot of money to buy servers. Rather, we trade that out for Opex, which is operational expenses. That is, we pay for operating the server. That is, we pay rent for the money that we use the server for. And this is actually not a fixed expense over the year. Rather, it's actually variable. So you can actually pay less because you use less, or you can pay more because you wanted to pay more because you're using more. So it's a variable expense Opex instead of a fixed Capex that you do at the start of the cycle. Number 2 is you focus less on your infrastructure, more on what your core business is. You take care of your applications, you take care of your customers, what is the benefit of that, rather than worrying, okay, what server do you need, what networking do you need, do you have enough people to maintain your server, have you put in the most important hardware related fixes. So all those things you don't need to worry on when you rely on AWS for the infrastructure. The third benefit of cloud computing as per AWS is don't predict the capacity. With cloud computing, you don't have to predict how much infrastructure capacity you need before you actually deploy an application. You don't have to predict it accurately. You can go with a good estimation, and you can scale up or scale down, and you can also automatically set up an infrastructure so that it scales up and scale down depending on different times of the day or depending on different months of the year. You can have this automatically scale up and scale down. So AWS, you don't have to really predict how much capacity you need before you start that. The fourth one that AWS covers is economies of scale. Um, what AWS says is that AWS and other cloud providers get infrastructure set up for multiple people around the world. So hundreds of thousands of customers, they aggregate their computing needs, storage needs, networking needs in the cloud. So AWS can achieve a higher economies of scale. So they can provide at a much lower cost to the customer. The fifth one is ability to increase the speed and agility. Using cloud computing makes it easier for somebody to actually develop an application and deploy it. If you have your own on-prem, you know that you would use at least like 5 weeks or 8 weeks of time before you can actually start like setting up your server. Your infrastructure team says your server is ready now, and then you can actually install the software needed, install the application needed, test the code that you need, and then implement it. But with cloud, you can do it in a matter of minutes. So with the right of a quick infrastructure as code, you can get it up in a few seconds, or you can go through a few clicks on the AWS dashboard. And it'll take you a few minutes, 5 to 10 minutes, to provision an EC2 instance or a Lambda function. So that way you can get cloud computing needs in a few seconds if you're using infrastructure as code, or in a few minutes if you're actually using the dashboard and building it. The sixth, and I think this is the major advantage that cloud providers provide, that companies are going to be really difficult implementing on their own. AWS has a global footprint. Even the largest like global companies like Coca-Cola don't have enough server capacity around the world, and they don't have enough edge locations. They don't have enough like networking capability so that they can connect every piece of their business. So these companies rely on cloud providers to get them to a place where they're able to do business from a global level. More so, if you're a company that's just starting up and needs a global footprint, AWS can quickly get you access to the whole world, and they can provide them with low latency to a user all the way across the world. So that's a huge advantage of cloud providers, as AWS puts it. So these are the 6 benefits of cloud. We'll definitely be asked a lot of questions about the benefits of clouds. The exam I wrote, I saw one of the questions about Opex versus Capex. I saw like a couple of questions about speed and agility, and I think that's all I did have about 3 questions, I think, from this. So let's talk about Opex versus Capex in our example. So in our example, while we have to build the chat application, if I have my own server, like if I need to start building the application, the money that I have to put in as a Capex to actually buy servers would run into tens of thousands of dollars. And I would need that initial investment, if I use an on-prem, to actually start building my application. So I have to put in tens of thousands of dollars to even get server capacity, and then I'll have to have my developers work on building this application. Rather, if I use the cloud, so AWS can provide this infrastructure to me by just giving my credit card. I don't have to actually pay any money when I start. And after the first month, if my developers have used so many minutes of compute power, I pay only for the amount I've used. So that is the difference between Opex and Capex. So Opex is operational expense. It's variable expense that happens month over month, versus Capex is a fixed expense that happens at the start of the project. there are some advantages with respect to finance, with respect to capital expenditure versus operation expenditure. You don't need to explicitly know this, but capital expenditure is preferred by some companies, especially because they can depreciate the asset. Capital expenditure buys you an asset, and that asset can be depreciated over time. And as you depreciate it, you can actually get certain tax benefits. So in some companies, there is an advantage of using Capex, and your finance team might actually prefer you to use Capex and build the infrastructure. But this is not in the scope for the exam. But it's good to understand that though Opex is what we will add by using AWS, some companies, not most of them, a few of them, like because of taking advantages of depreciation and thereby their tax advantages, they would prefer to have a additional Capex, that is upfront infrastructure cost, rather than variable operation expenditure. So next we look at the same example on the second cloud benefit, which is how do you focus less on infrastructure, and actually focus on the actual application that we're building. So now that I'm not going to buy servers, I'm actually going to use AWS. What can my time be spent on? Like I can spend about the first day or first half of the day working on what infrastructure we need, and then actually setting it up on AWS. And the remaining part of the week can actually be spent on spent with application developers, talking about what the functional requirements are going to be, how they're going to build it, what kind of software we need to install to get this done, what kind of architecture we're going to use. So we can talk about all those things starting day one. While if this is going to be on-prem, I would have to set up the infrastructure in like 4 to 5 weeks at least, even if it's a very small infrastructure. So I'll have to order for infrastructure, get a place that is ready for it, somebody will come and install it, make sure all the hardware related fixes are done and it's updated, and then we can actually start putting in some dev tools and installing our development related tools inside them to actually make it functional. We'll go to the third benefit of cloud computing. We don't want to predict capacity. So now that I'm building a chat app, I don't know how many people are going to use it. I don't know if this is going to take off heavily. I don't know which part of the world is going to use this. If it's mostly going to be people from the region I am building it in, or is it going to be a country which is far away, and that's where the users are. So I don't have to predict all that. I don't have to predict how many people are going to use it. I don't have to predict how much server capacity I need based on that. I can focus on building the application and worry about like capacity based on like what I actually see. And there are also ways to auto scale in AWS, and this is one concept we'll definitely cover during this, but I don't want to go over it today. But that will be covered in the course of the Cloud Practitioner training. The fourth benefit of cloud computing as per AWS's list is economies of scale. The advantage of AWS provides to me is that if I buy server capacity from say HP or IBM and they provide me server, I pay them a very heavy cost, and then I will have to manage the actual cloud. So I'll have to manage a location for it. I'll have to make sure that's climate controlled, like it doesn't have too much humidity. I'll have to make sure that premises is controlled from a security perspective. I'm also going to maintain something called redundancy for high availability and redundancy. I'm probably going to build a similar set of servers in another location as well. So all these things would cost me a lot of money, and I will have to put in expenses for security and climate control and any hardware fixes I need to put in some administrator to actually work on those. But AWS does this for all their servers at their location at a very massive scale. So they can do this at a much lesser cost than me paying tens of thousands of dollars to HP or IBM to get these servers in and have an administrator actually work on like fixing, putting in the fixes and for rental capacity, security, everything. Like the next or the second last benefit that we have of cloud computing is increased speed and agility. So I would be able to try using one architecture and building it over the first sprint of 2 weeks, and then I realized that that is not the best solution for me, and I would have to actually change it. So that is a kind of advantage that I can get with respect to AWS. So let me give you an example. So we are going to build this using a Linux server, which we think is the best way to solve this. And after 2 weeks, we realized that that is not the version of Linux we need. We're going to use a different flavor of Linux because it provides additional security facility that we actually would definitely require. So if we have this server on our own, then removing the OS and then building another OS on top of the server infrastructure that we have would take us like at least a week. But it will also mean I will have to shut down the old instance before I try the new instance because I have limited server capacity. I will not be able to immediately move from one to the other. While in AWS, I could have both of them running for some time to understand and test which is better. So that way I'm much more able to test both of them, and I will also able to get this set up in a much quicker fashion. I can write the infrastructure as a code and do it in a few minutes. So that would increase the speed and agility. And agility in this sense means that we're able to adapt from one to another and in a very quick fashion. And we're able to, the speed in this sense means that we're able to set up either Lambda functions, EC2 or any type of storage very quickly. Okay, the last advantage is we are able to go global in minutes. Like even if I set up the Chatter application in my own basement, so that I kind of don't pay for any rent in addition to what I already do, I still can be able to set the infrastructure up. But from somebody from Thailand or somebody from Australia who's trying to access this messaging app would face a long network wait time. I wouldn't be able to provide them with global benefits of the cloud. So I would not be able to have a quick turnaround for them. So for them, it's going to be really slow. The application may not even respond within a given time, and it might time out, and they may face the page may not refresh for them. So it might be a nightmare for me to get global customers. But with AWS, the biggest advantage is that they already have a global presence, and they have infrastructure set up in all continents except Antarctica. So they have a very global reach. They have a huge computing capacity in a multiple regions across multiple continents. So we look at that as well as we go along. But those are the 6 benefits of the cloud. Let's look at one of the questions that gets asked with respect to the concepts we have covered till now. If you remember, we spoke about Capex and Opex. This is one of the tricky questions that I did see. So the following are the economical advantages of using AWS. Choose 2. Number 1 would be reduced total cost of ownership. For this one, I think typically cloud could be cheaper than on-prem, but not always. So this is most probably true, but I'm going to look at the other options before I decide. B is increased capital expenditure or Capex. So capital expenditure is not going to be like increased because of cloud. In fact, we're not going to have any capital expenditure or we're going to have very minimal capital expenditure for other reasons. But when we set up a infrastructure in AWS, it's not going to have any capital expenditure. We're going to pay as you go. We're going to pay as operational expenses. C is reduced operational expenditure. Actually, we don't reduce our operational expenditure. We actually increase our operational expenditure. Earlier, we just pay for maintaining the server, but here we actually pay operational expenditure for renting the server from AWS, for renting storage capacity. So it actually increases operational expenditure. So I'm going to say no for C. For D, deferred payment plan for startups. This was pretty close to me. I was not really sure. I had to search it up. Turns out that AWS does have business credit lines for startups. Not really a deferred payment plan. So it's not really D, but it was E. So this one I was not really sure based on my preparation. I had to search it up after I prepared for it. But in this case, the answer turns out to be A and E. The next concept that is really important for the cloud examination is the WellArchitected Framework, or the 5 pillars of AWS WellArchitected Framework. So AWS link for AWS WellArchitected Framework would be provided in the description, so you can go through that. But I'm going to cover most of the important pieces that you would need to go through anyway. The 5 pillars are operational excellence. So that means you're able to provide the best operations for your application. You're able to have so before I tell you what the 5 pillars are, let me tell you what a well-architected framework is. So AWS has built out a well-architected framework. So any application that is built on the cloud, they suggest us to understand what a well-architected framework would look, so that when we architect our application, we keep those in mind. We make sure those considerations are met when we actually build our application. So to achieve a very good architecture, if you keep these in mind and make sure these are taken care of, these 5 pillars would enable you to make a very good use of the AWS cloud, and would make your application well suited for the cloud, and is a very good application in general to be working with. So the 5 pillars are operational excellence, security, performance efficiency, cost optimization, and reliability. We'll go over them a little bit more in detail. So the AWS WellArchitected tool, there's a tool that they provide. So it's kind of a internet questionnaire that you go through, and at the end, AWS makes recommendations for what kind of workloads you have. You could see this in the right in gray. It talks about that tool the tool, after you answer the questions, it kind of gives you out some recommendations. So what kind of high availability should you use? What kind of security should you use? What kind of networking should you use? So those kind of suggestions are provided by AWS at the end of the questionnaire. So that can help you build or architect within the AWS well-architected framework. So I mentioned that only because there could be a question that comes out about the well-architected tool. I have used it and I don't see that as being very useful, but it does provide recommendations for architects who are new into cloud, or for architects who don't have a very good understanding of how to build their applications. But to me, I was not very impressed with the AWS well-architected tool. But yeah, you could anyway have exam questions about it, so you have to know about it. So the five pillars of AWS well-architected framework, we'll come to that. So on the left, I'll start with operational excellence. What do you mean by operational excellence? You're able to run and monitor the systems to deliver business value and to continually improve supporting processes and procedures. So operational excellence, I'll just talk about that quickly. So we want to run your system so that your application provides business value to the customer, and it also is able to improve the supporting processes and procedures. So that's what we mean by operational excellence. This is in a way how well is your application well suited to provide business value and to make it such that your supporting process and procedures are improved every time. So that's essentially what operational excellence is. Are you supporting your business? Are you able to improve the process by which you support the application every time? The next thing is security. It's self-explanatory. What we do is we make sure the application is well protected. It protects the information from other people getting in and getting the information out. It also protects the systems. Nobody can come in and inject code into it or implement code that you didn't want into it. It also protects the assets, including information, including any other proprietary logic information. You do all this security information even though you provide business value, and you do this through risk assessments and mitigation strategies. So what this means is, just because you take security into consideration so that you protect your information and assets doesn't mean you don't provide value to your customers. You will have to provide enough information to your customers so that they can work on what they need to work on. But you provide that in a secure fashion. So you protect your information, encrypt it when you send it across the internet, encrypt it at storage. So when you store it somewhere, you encrypt it at rest. So that is another way to protect your information. You also make sure there are no ways. You have multi-factor authentication set on so that people cannot learn the password, guess the password, and get into your system. So you make sure all your code is cannot have any SQL injections or any other type of malware easily installed. Make sure all your business core information that you want to keep proprietary is well within a secure gateway so that nobody can get into. The third of the 5 pillars is reliability. We want to be able to recover from any service disruptions. We should be able to acquire more computing resources on demand, and we should also be able to mitigate disruptions. If some region goes down, some server is down because of like either multiple requests that we get or because the region is down, we should be able to mitigate the disruptions and still work with them and get back online pretty soon. So that is reliability. So for this pillar, it's important to understand that you will have to build based on a few factors. Like we'll have to understand certain terms such as redundancy, high availability. So one thing we need to always keep in mind is most applications do fail at some point of time, either because there is too much traffic or because there is some unknown like network issue, or there's some way where there's a power shutdown in a region. There could be a natural disaster. So there could be so many other things. We have to have enough ways to recover the information that we had, either because one of the hardware disks failed. Do you have the same information in another hardware disk? If there's a server that's running right now and it got disrupted because it lost network capability, do you have a similar compute instance or similar computing capability in another region, in another place? So can you do that and reliably be able to meet the customer's needs? Even if this particular request is not met, can you get back online in a matter of minutes or at least an hour, depending on what your business needs? Can you do that? That is reliability. Performance efficiency is what the next one is. I think that is another one that is self-explanatory. So how are you able to effectively and efficiently use computing resources to meet the system requirements? And how do you maintain the efficiency as demand changes and technologies evolve? So this is the most important piece. As we saw earlier, speed and agility is one of the huge advantages of cloud. So as things change, we want to be able to meet the capacity by increasing the capacity. So if more people start using it, we add more to the server capacity and we scale up. And as demand goes down, we should be also able to keep it efficient, not have unnecessarily high compute capacity, even though we don't need it. We may need it. So how do you scale down? That's a huge advantage. And the other piece about agility is where when technologies evolve, are you able to move from one technology to another in a very efficient manner, cost efficient manner, easily able to adapt? So that is also part of performance efficiency. Cost optimization is the last one, where we run the systems so that it delivers business value, but it does it at the lowest price point. So 5 pillars of AWS WellArchitected Framework. I think this, I did not get a question on this, but what you read on the internet is that every other person definitely does get a question on the AWS WellArchitected Framework. This is one of the most important cloud concepts. The next one is the 9 design principles that AWS provides. I'll provide a link of that as well in the description below. This is going to understand a little bit about how you enable scalability. What happens, are you able to scale up and scale down? Are you able to automate your environment? So that's one thing AWS recommends that we keep in mind when we design our application. Are you able to automate your environment so that you can build infrastructure as a code rather than somebody actually doing it and say they click the wrong button, or they provide the higher or lower capacity than what you need. Rather, if you have a computer, script it and do it every time, it would do the same thing repeatedly every time. Are you able to use disposable resources? That's another design principle that's really important. As I was saying in the previous important thing when we talked about the five principles. Um, so here we talk about Werner Vogel's concept where everything fails all the time. So we have to keep that in mind and make sure we are able to replace the broken things quickly and without spending a lot of time and money on them. So how do we do that? So that's what we keep in mind. So that is one design principle when we do any cloud related architecture. Are we able to use disposable resources? Are we able to use something, and if something doesn't work, can we just throw it off and move on to another way to do it? Are you able to loosely couple your components? So these two are special things that get asked multiple times in the exam: disposable resources, and are you going to loosely couple your components? So these two definitely get asked a lot. So I will dig deep into them in the next few slides. Those are concepts 9 and 10. So design principles, design services, not servers, is the next one. So we don't want to be working on the server infrastructure and server work, because any business would need to serve its customers, and that's the most important piece. Their focus should be on rather on how to actually build applications, how to serve the customer. Everything else should be taken care by AWS. Next one is to understand your single points of failure. So understanding single points of failure will help you either eliminate them, or you can have multiple redundant systems, so that if it fails in one place, there's another place where which can pick it up and do the same work. So as I spoke about earlier, if all your data is stored in one hard disk or in one database, are you able to make a copy of it on a regular basis, either every second or every hour or every day? Are you able to copy it over to another place so that you don't really, when something fails, you don't really lose all that information because you have a backup somewhere else? Or when we are running a server and that server is out of network or is out of capacity, do we have another server which is on standby, which can pick up that work, or the pick up the requests that come after the failed request to be served by that server and responded to immediately? So can we do that? So those are things you need to keep in mind when you design your application. You always want to optimize for cost. So make sure whatever capacity you're actually provisioning, you're actually using. So AWS has some tools to keep you alerted. There are some billing alerts that you do. Make sure you're using enough. You're not using too much than you would rather need. So those kind of things. There are some billing alerts to be done, and there are also certain other tools which let you know if you're using the optimal capacity. If you have too much provision, you don't need to provision as much. So AWS has tools for showing you that, and there are also some billing alerts that you can put in to know if you're misusing some resources, you're overusing some resources that you should probably not be. You could set up those as well. The eighth design principle that you need while designing any application on the cloud would be to secure infrastructure at every layer. So security vulnerabilities can happen by threats from people around the world who can break into your system by trying in multiple avenues. So make sure you have a secure infrastructure in every level. Your application is secure not only, but your infrastructure is secure. Every network ingress or egress you make sure that is it's authenticated. We're not having any unknown IPs attempting to reach that. So make sure all that infrastructure is secured at every layer. And the last design principle is to use caching. Like your data is not of the same value or location, nor are the resources of the same cost. So understand when you need to cache your information, especially this is a concept that you will use when you have some data that is requested by most requests in the application. Say for example, for our chat application, we might like require the server time to be sent out, like for every API request. So that might be something you cache on your server, so that that can be retrieved pretty quickly. Or if you want to have a dashboard that shows up every for every application. Actually, for the chatting application, I don't know which information would be cached other than like the most requested users. Chats could be cached, but if it's a peer-to-peer chat, we don't really cache that information on the server. We rather cache the meta information, not the real texts. So I have to think about what we'll cache for our application. Okay. The remaining concepts we'll cover in tomorrow's session would be loose coupling, which is one of the design principles. Disposable resources, that's another design principle. We'll talk about high availability, and how availability zones in AWS provide the high availability that we need. We'll also talk about the 6 core perspectives of cloud adoption framework. We'll go through these questions and try to answer them. I'll explain all these questions in detail in the next session. Okay, for today's session, we covered all the cloud concepts that we need from cloud basics. So tomorrow we'll continue with the cloud basics topic. We will go through more information on cloud basics, go in with a lot of questions, and then we will provide more resources in the bottom links, so that you can read more about it, and also certain questions that you can actually practice and get completed. So thank you for watching. If you liked this, please hit the like button. I would appreciate if you can subscribe to this channel. You would benefit by following us for any more AWS related material. And this 2-week course will also help you complete the AWS Certified Cloud Practitioner course. So find the next video for day 2 and watch that as well. Thank you.